31 question. In which of the following compounds transition metals has zero oxidation state? And obviously you can get the answer D, because in D this carbon monoxide is a molecule, and this molecule that equal to zero oxidation state. Here oxidation state is 0. So my dear students, this option is D, because iron has also this zero oxidation state. X plus 0 that equal to 0. So you can get X is equal to 0, you can get here. Now we can go to the question number 32. Which one of the following ionic species will impart color to an aqueous solution? My dear students, concept is this: though solution gives colored solution in which D10 or D0 is present are colorless, other are colored. Here D0 and D10 are colorless. If you can see this example, copper plus, you can get the 3D10, because here only one electron is removed, and this electron is removed from 4 as 1. This electron is removed from 4 as 1. So my dear students, you can get the 3D0. So it form colorless. In this way you can get the zinc form colorless, titanium plus 4. That's why perhaps you get the answer chromium. First of all, you can see the atomic number of chromium, Sc, T, B, Car means 24, atomic number is 24, 3D4 and 4s2, and this electron go to this d orbitals, that's why it is called 3D5, 4s1. My dear students, when this chromium is converted to chromium plus 3 ions, you can see here in this 3D in chromium plus 3 ion, 3 electrons are removed, 1 electron is removed from here and 2 electrons are removed from here, and you can get, my dear students, 3D3, 4s0. In this way, my dear students, 3 electrons are present in d orbitals. So this chromium plus 3 show the color in the aqueous solution. So you can go the answer D, question number 32. My dear students, we can go to the question number 33. In this question number 33, 1996 in here, this questions come in neat. So my dear students, here electronic configuration is there 3D4 in its plus 3 oxidation state. If 3D4 in plus 3 oxidation state, you can add these 3 electrons, and 3D4 and 4s0 is obviously there, because electrons are removed from s orbitals. So 2 electrons are go to this, so you can 4s2 and 3D5. So outermost electronic configuration is present 3D5 4s2. So my dear students, 3D5 means you can go to the 25 atomic number, because here this 5 give us 3D5 electronic configuration, 2 give us 4s2 electronic configuration. So my dear students, when you see the question number 33, you go to the option C in this way, and this is also a trick for calculate the atomic number and electronic configuration. My dear students, when we see the question number 34, among us TiF6, CuF6 minus 3, Cu2 Cl2 and NiCl4 minus 2, which are the colorless species? Here my dear students, colorless species, here you can see the Cu2 Cl2 plus 1 oxidation state is present. So here I see this plus 1 oxidation state, so answer is this one, or plus 1 is present in this C option, so answer is this one. Because in plus 1, copper present in 3D, 0 d orbital is completely filled, so it forms colorless. Now we can see here titanium. In titanium, you can calculate the oxidation state in titanium. Concept and theory and reaction. Here my dear students, in titanium you can get the X oxidation state, because we can calculate the oxidation state of titanium. X minus 6 is equal to minus 2. So, you can get the X that equal to minus 2 plus 6, and you can get the X is equal to plus 4. In this way, my dear students, you can get the X is equal to plus 4. When X is equal to plus 4, titanium, atomic number of titanium is that equal to 22, here given in the numerical this question. 22 means this belong to d orbitals 3d2, this belong to d orbital 3d2, and this belong to s orbital 4s2. When, my dear students, this titanium is converted into titanium plus 4, because in this ions titanium present plus 4 oxidation state. So, my dear students, titanium leave 4 electrons from the valence shell. So, you can remove these 4 electrons 2 and 2. So, you can get the 3d0 and 4s0. So, my dear students, here titanium plus 4 also get the 3d0 electronic configuration. When d0 and d10 electronic configuration are present in the salts, those salts are dissolved in water or formed colorless species. So, my dear students, you can go the answer B. Question number 34, answer is B, and this question is asked in 1995. Now, my dear students, we can go to the question number 35. Here this is the question number 35. The mercury is the only metal which is liquid at 0 degrees Celsius. Here, my dear students, this is due to high vapor pressure, weak metallic bonding, and high ionization energy. My dear students, it is a theoretical question that you can get the in mercury high ionization energy is present and big metallic bonding is present, that is why it is a liquid state. So, you can go the answer D. In mercury, weak metallic bond is present, big metallic bond is present in mercury, number 1, and number 2, high ionization energy, because in mercury you can see the electronic configuration is 5d, 10 and 6s2. This is the outermost, electronic configuration outermost electronic configuration of mercury. So, my dear students, you can go the answer option D, answer is D. Question number 35, this is asked in NEET 1995. Now, my dear students, we can go to the question number 36. The magnet and permanganate ions are tetrahedral due to. Here, my dear students, here you can see the O, K2MnO4 and KMnO4. When you see the KMnO4, it is a potassium permanganate. And when we see the K2MnO4, it is a potassium magnate. In potassium magnate, you can see there is plus 1 charge present potassium, so minus 2 charge is present in magnate. Here you can see the only minus 1 charge present in potassium permanganate. Here, my dear students, when you see the structure, for this magnet, 2 negative charges present, 1 and 1, and you can note very well oxygen atom is bivalent. So, you can double bond is present between oxygen and manganese. So, this is a structure of magnet. Here you can see the structure of permanganate. In permanganate structure, only one negative charge is present and other manganese and iron, manganese and oxygen, here double bond is present. So, my dear students, we can see here, this is the structures and here tetrahedral structure are present. Here manganese d orbital is present. Here you can see the d orbital is present in this manganese. Now, my dear students, when we see the oxygen, d orbital is absent in oxygen, only p orbital are present, p, p and p. Same is condition present in permanganate. So, tetrahedral structure is present by the overlapping of orbitals. Here you can see the d orbital has present in manganese and p orbital present in oxygen. So, my dear students, here d and p overlapping are present in this magnet as well as d and p overlapping also present in permanganate. So, my dear students, these are the same type of overlapping is present, and when same type of overlapping are present, so structure molecular geometry is same. So, my dear students, you can go the question number 36, that is the answer is B. You can go the question number 36, answer B. And this question is asked in NEET 2019. Now, my dear students, we can see the question number 37. When neutral or faintly alkaline KMnO4 is treated with potassium iodide, iodide ion is converted to X. X is, here you can see the reaction. What is the reaction behind this? When this KMnO4 reacts with alkaline or neutral means water, H2O plus here Ki. Because this Ki is called, my dear students, potassium iodide. This Ki is called potassium iodide. When this KMnO4 reacts with water plus Ki to form iodide ion is converted into X. This is called iodide ion. So, iodide ion is converted to X means it is converted to KiO3 and it is called iodide. Plus, my dear students, KMnO4 is converted to MnO2 plus you can get KOH. Here 2 potassium are present, that is why you can balance this reaction, and this is balanced by twice KMnO4. Here you can see here this K plus and IO3 minus ions, it is called potassium iodide, and from this potassium iodide you can get the iodide ions. This is the reaction of KMnO4. And this reaction is already given in your books, and in Odisha NEET 2019 this question is asked. Here some technical points is there. KMnO4 plus potassium iodide, potassium iodide is, it is a theoretical, it is written in this question, but potassium iodide is a Ki and is converted to potassium iodide. So, my dear students, you can go the answer C. Question number 37, you can go the answer C. Now, my dear students, when we see the question number 38, and this question is asked in NEET 2018. Which one of the following ions exhibit DD transition and paramagnetism as well? My dear students, here you see the MnO4 minus 2 ions, In MnO4 minus 2 ions, this is KMnO4. KMnO4 always convert to MnO2, or it is also converted to MnSO4. In MnO4 minus 2 ions, you can see here oxidation state X minus 8 is equal to minus 2. That is why you can get the oxidation state of plus 6. And when this oxidation state of plus 6, and in this MnO2 you can get the plus 4, and MnSO4 you can get the plus 2. In my dear students, in MnO4, Mn plus 6 oxidation state is present. In manganese, Sag, T, B, Kar, Man, 25 atomic number is present. It is 3d5 and 4s2 electronic configuration. When, my dear students, in MnO4, in this ion, oxidation state is plus 6, it means Mn is converted to plus 6 oxidation state by the removal of 6 electrons. You can get the 3d1 and 4s0, because 2 plus 4, 6 electrons are removed. So, oxidation state of this Mn plus 6 is 3d1 4s0. Here, my dear students, 1 electron is present in this manganese Mn plus 6. So, here dd transition is take place when you can get the T2G, 3 electrons, 3 orbitals are present, and Eg, 2 electrons are present. Here it is a T2G and Eg, d orbitals are present. So, when this 1 electron is present in T2G and this electron absorbs energy in the form of quanta, then this electron go to the Eg orbitals. And my dear students, when these electrons go to the Eg orbitals, means it accept the energy and limit the different energy. So, it forms a color. And due to the presence of 1 unpaired electrons, my dear students, it shows a paramagnetism, color and paramagnetism. So, we can determine the color and paramagnetism by these ions, which ions given in our options. First of all, you can find out the oxidation state, and after oxidation state, you can see the electronic configuration of metal and see how many electrons are removed from this valence shell. If valence shell you can get the electrons, then you can take this is a dd transition, or due to presence of this all are unpaired electrons means paramagnetism, and when all paired electrons are present, it is a diamagnetism. So, here you can see chromium, and here you can see this chromium, all electrons are present in paired. In MnO4 minus 1 charge, here my dear students, you can see the oxidation state. X minus 8 is equal to minus 1, that is why oxidation state is plus 7, and plus 7 oxidation state is present, means 5 electrons and 2 electrons are removed from this manganese. When electrons are not present in d orbitals, so dd transition is not take place in MnO4 minus 1. In this way, you can calculate all the CrO4 minus 2 and Cr2O7 minus 2. So, my dear students, your answer is MnO4 minus 2. Answer is D. Question number 38, you can get the answer. Now, we can see the question number 39. In 39 question, name the gas that can readily decolorize acidified KMnO4 solutions. My dear students, what is the reaction? You can see this reaction in KMnO4 reaction. When this KMnO4 is reacts with this SO2, sulfur dioxide, and in presence of H2SO4, Because my dear students, here in this question acidified KMnO4 is given. So you can find out K2SO4 plus MnSO4 and plus water. So by this section you can see here KMnO4 solution is decolorized by this SO2 gas. So your answer is A and reaction is this one. Now my dear students, we can go the question number 40. Now my dear students, this is the question number 40. Which one of the following statement is correct when SO2 is passed through acidified K2CR2O7 solutions? Here my dear students, you can see the reaction. In this reaction, this is the direct reaction K2CR2O7 when reacts with H2SO4 plus SO2. You can get the Cr2SO4 whole thrice, and this is the green mass you obtained, plus K2SO4 is formed and plus water is formed. So my dear students, here answer is B, that is green Cr2SO4 whole thrice, chromium sulfate is formed and it is a green mass. So my dear students, when you can in acidified K2CR2O7, you can pass this SO2, SO2 is converted to Cr2SO4 whole thrice. Now my dear students, we can go to the question number 41. Assuming complete ionization, same moles of which of the following compounds will require the least amount of acidified KMnO4 for complete oxidation? Here my dear students, you can see here, that is the when you can see the concept of this question. When you can take this A part, A FeSO3. In FeSO3, here Fe plus 2, here plus 2, convert into Fe plus 3. So here only one electron is removed. This SO3 minus 2 is converted to SO4 minus 2, then you can see here 2 electrons are added. Here we can see the B option, FeC2O4 iron oxalate. Here Fe plus 2 is converted to Fe plus 3. So it remove one electron, and when C2O4 minus 2 convert to twice CO2 and it remove 2 electrons. Here my dear students, C option, FeNO3 whole twice. Here iron Fe plus 2 convert into Fe plus 3, only one electron is removed, and when this twice NO3 minus here you can see this twice NO3 minus, so twice NO3 minus is converted into NO2. So you can remove here 2 electrons, this is required. Now when see the FeSO4, here my dear students, FeSO4 plus 2, here Fe plus 3 is converted, it's only required one electrons. So will require the least amount of acidified KMnO4. My dear students, those compounds in which number of electrons are required least, then it is converted into least amount of KMnO4. Here in FeSO4, SO4 minus 2 ions convert to SO2, so only one electron is removed or required. So KMnO4 is required 1 mole. So my dear students, your answer is D, FeSO4, and this question is also come in 2015 NEET exam. Now my dear students, we can see here question number 42. The reaction of aqueous KMnO4 with H2O2 in acidic conditions gives. Here my dear students, you can see the reaction. What is the reaction when this KMnO4 reacts with water? Because here you can see the aqueous KMnO4, aqueous means water, plus H2O2 is there. In acidic condition, H plus ions are also present. It means KMnO4 plus water plus H2O2, or H plus ions is given by this H2SO4, it is converted into K2SO4 plus MnSO4. Due to this H2SO4, these are converted, and hydrogen peroxide will give us oxygen because it is decomposed to water and half O2. My dear students, here you can get the Mn plus 2 ions from MnSO4. So, you can get Mn plus 2 ions and O2. So, your answer is B, question number 42, your answer is B. Now, we can see here question number 43. Which of the statement is not true? On passing H2S through acidified K2Cr2 solution, a milky color is observed. Yes, milky color of sulfur is observed there. Number C option, K2Cr2 solution acidic medium is orange. Yes, it is orange color. K2Cr2 solution becomes yellow on increasing the pH beyond 7. Yes, when increase the pH, then color of the K2Cr2 is yellow due to the formation of due to the formation of Cr2O3. Now, we can see here sodium dichromate Na2Cr2 is preferred over K2Cr2 in volumetric analysis. No, not at all. Because potassium dichromate is a concept, K2Cr2 K2Cr2 is hygroscopic. K2Cr2 is a hygroscopic in nature. So, my dear students, here you can see when this is the hygroscopic in nature, means it's absorbed, means K2Cr2 absorb moisture. Moisture from the air. So, my dear students, answer is your answer is B, question number 43. Now, we can see here next question, that is question number 44. Here acidified K2Cr2 solution turns green when Na2SO3 is added to it. This is due to the formation of, my dear students, what is the reaction? Reaction is this, K2Cr2 reacts with this H2SO4 plus this Na2SO3 to give here K2SO4 plus Cr2SO4 whole thrice plus Na2SO4, because one oxygen atom get this sulfide ions and convert into sulfate ions, and plus water is removed. Here, my dear students, color of this color of solution or green color of solution is given by this Cr2SO4 whole thrice. And this is question is asked in 2011 NEET exams. If you know the reactions of this potassium dichromate, which is given by these videos or my package, and you can get this all reactions in my package. I am also repeat these reactions in this crash course also, my dear students. So, this potassium dichromate reacts with this sodium sulfide. This compound is called sodium sulfite. Here this sodium sulfide is converted to sodium sulfate, and green mass is obtained from chromium sulfate. Now, my dear students, we can see the next question, question number 45. Question number 45 is asked in this 2005 NEET exams. Here, my dear students, the number of moles of KMnO4 reduced by 1 mole of Ki, and solution is alkaline. My dear students, solution is alkaline and neutral, both are same in nature. So, you can use this equation, and this reaction is also given by me before 42 or 41 questions. Now, you can see that reaction is same. Potassium iodide is converted to potassium iodide, plus you can get here this MnO2, plus you can get this twice QH. Here, my dear students, because twice QH is obtained here, so 2 mole of KMnO4 is reacts with 1 mole of Ki, and you can get this potassium iodide. So, question is that number of moles of KMnO4 reduced by 1 mole of Ki. Here, my dear students, this is a 2 number of, because 2 moles are required for this reaction. So, 2 moles of HI, 2 moles of KMnO4 are used in this reaction, and you can get potassium iodide. So, you can get the option B, question number 45, you can get answer B. So, my dear students, in this D and F block elements, we can solve all the questions which are coming in NEET exams from 1994 or 1989 to 2020 up to 2020, and we can see all the concept, very important concept, as well as all the detailed reactions in which questions are asked. So, my dear students, I hope you can learn and you can remember these reactions and remember my tricks which are given in this chapter. Thank you.